Hi, I'm glad I caught you before everyone else came in. I'm on my mom's laptop. That's why it says Kim Maximic instead of my name.
There we go. I was having a heart attack because I was like, I don't know who this person is, and
Yeah,
so
no, I'm sorry.
I'm like, I hope I got the link out to the right people. You're
Yeah,
totally fine.
so my mom usually is able to let me use her laptop. If she has work or something or her own Zoom meetings, I have to be on my laptop. I'm still trying to figure out a long-term solution, but right now my computer camera is not working.
It's okay. It's totally okay.
Okay, great.
Understand. Let me know if there's anything I can do to help.
Great. Okay, awesome. Thank you.
I'm gonna start letting other people in real quick, okay?
Oh yeah, perfect. Thank you. Here, I actually have to do one more thing before class.
Yeah, let me see where we were at. I was trying to get this up.
Good morning.
Morning. Hold on a sec. Okay, I'm gonna be on the phone with my students, okay? Hey, we're getting there now. Let's see. Okay, I think we're at time, huh? I was waiting for people, but we can let them in as time goes on. How's it going?
It's all right. It was
Good.
stressful.
Stressful?
Yeah,
And
having to move
anything
in
in
yesterday.
particular, or just, I mean, that's a reasonable response to 2020.
No, just moving tomorrow, or not tomorrow, yesterday, and then having to keep up with homework and everything. For the weekend.
Yeah, that is rough. But you're all in, you're settled, you're good?
Yeah, I'm all good. All good. Got in okay.
Okay. I will have to do that later, dear. I have, I'll explain my situation while we're like theoretically waiting for a few more people. My daughter was in in-person school all but 4 days, where she was sent home with a runny nose and a sore throat. And theoretically, that's 2 COVID symptoms. And so like the school did the right thing. It's good to send her home. She shouldn't be there if she theoretically has COVID. We took her for a COVID test. She seems fine, but I have to wait till I get a negative test result before I'm allowed to send her back to school. So that's why I'm remote today. So one of the questions I think people had is like, well, will we be in person on Wednesday? And my answer is, I hope so, but I don't know, because I don't know when I'm going to get that COVID test back and have her go back to school. So I will keep in touch with you all. I will let you know via email again if we're going to be in this format or if we'll be face-to-face on Wednesday. You know, I have hopes that we'll be together on Wednesday. But for now, this will do for us. I can say for sure that I can be there Wednesday evening. I have in-person office hours that are just for abstract algebra. And at that point, my partner will be home, and so he will be able to stay with the children. So I can come in on Wednesday night for sure for that in-person office hour if that's appealing to you. I reserved our room. DSC 255 is where we will meet when we do meet in person, and I've reserved that room for office hours on Wednesday so that we're in a larger space should there be people there and not like trapped in my office. So that's the update I can give you for Wednesday. I also have the little one working next to me, so if you hear another voice or if I'm interrupted, that's where that's coming from. Let's see. So I have you all here. That makes me happy because I have people to talk to that are adults. I have the questions for class on September 14th. I have some exercises and like math we can do together, but I feel like all of that is like kind of jumping the gun. Like before I like just get into that to-do list and go, I just want to give you a chance to like ask any questions you might have that are like really pressing or anything I can tell you. It's the 14th, Clara. Doing okay? I'm totally cool with you having your cameras off too, by the way, like that's fine, but if like a little thumbs up emoji is helpful every now and again, or like, yeah, we're doing great in the chat. Oh, that is helpful to me so I can just make sure that we're on board. Yay, thanks, Liz. Thumbs up, I'll take it. Okay. Should I start with the questions from the course log? Because that was really helpful for me, having questions there. I think there are a handful of questions about like homework, and there are some questions about just like how everything is going to work, I feel like in general. So that's a pretty good place to start. So one thing that I did, so for your first homework, first of all, did you get your feedback? For the most part,
all in the same order.
Yay, I got a thumbs up. We did get feedback. But actually not the person I'm looking for gave me a thumbs up because for most people, I just recorded my voice talking through your homework assignment. For some people, it's mostly because it's really hard to type math, right? Like we're in this weird situation where you can't hand physical papers to me and I shouldn't hand physical papers back to you. That's just a step we don't need to take. But there's like a little, like I can put a comment icon in Schoology where I could type comments to you, but it's really hard to type math without special software. So it's hard for me to convey my comments to you in a typed comment. So what I've been doing instead is recording audio. I look at your homework and I go through your homework and I say like, oh, I'm looking at problem 2 and I'm looking at this line, and I say out loud the mathematical things, and I'm hoping that that will be helpful for you. But as we're remote or as we're distanced, the concept of like showing each other our math work is going to be a little bit hard. So that's one of the reasons I wanted us to have these little whiteboards for when we're in class and for when we're here, because it might be hard for us to say like, I'm looking at this thing. You can write your math on something clean and nice, and everyone will be able to see it. So I think that that is helpful. But aside from the feedback on the homework, here's the #1 feedback I want to give to absolutely everybody, right? Super important, so I'll wait till these next 2 people get in the meeting before I say it. There we go. In terms of the homework, partial credit. Don't turn anything blank into me. That's garbage, that's nonsense. If you draw me a picture of a cat, I will give you 4 points out of 10. I'm not joking, I'm being serious. I've done it. I get many drawings of cats, I like them, right? So put something down, hopefully it's, I like the cats, but I promise you had ideas and you had thoughts about a thing. And I know that you don't feel good about turning something in that isn't complete. I get that. I don't like turning things in that aren't like my best work either. But if you turn something into me, it lets me know what your thoughts were. And it's very hard in a proofwriting course to feel to feel 100% confident in all the things that you're doing. And so it makes you feel like you want to write nothing. But please don't. Write whatever you have. Write whatever your thoughts are. For a couple of reasons. The first reason is, I promise you have better thoughts than you think you do. You just don't feel great about it because this is all new to you, and that's understandable. And second, for me, sometimes writing down the things that I know, it's like a spark. It helps me say like, oh, I know that thing. That could be useful, and it helps me come up with the next thing to do. So when you're saying that you're feeling stuck, sometimes writing down what you know and what you don't know is helpful. But I don't know about this, I don't know about this. It helps me understand your thought process. It helps you get the ball rolling. It lets me give you partial credit for trying. So please, on your homework, just write whatever thoughts it is you have. If you can't finish something, that's totally okay. That happens sometimes. But write something down so I can get you partial credit, even if it's a cat. Yes, we can do that. We like cats. If you like dogs, that's cool. I can take a dog. I like dogs also, right? Awesome. Okay. Feel free to chime in if you have other questions, right? But I can keep going from the course log. Yeah, okay. So more structure. So I gave you the update on my daughter and why I am from home today, why we are Zooming today. I have hopes that we'll be in person on Wednesday, but I'll keep you updated on that. But in general, if things go well, what is this class supposed to look like? Like, are we still doing videos and what? Like, I think that was one of the #1 questions. It's like, what are we supposed to be doing? So let me explain the general philosophy in hopes that that helps. My dream for us in this class is to make it so that if somebody has to miss sometimes, it is absolutely no big deal. That everything will go on. Because if you're sick or if you're stressed or if you are taking care of someone who is sick, like, I don't want you to be like, well, if I choose not to go to class, then I'm just going to be screwed and I can't do my work. Like, I don't want you to feel that pressure. So what we will do throughout the semester is I will always be making videos of lecture content. Always. I will record the videos for YouTube that are like, this is the definition of a group, right? And then what are we going to do so that if you're missing class, you always have access to that lecture content and you never have to miss that and try to piece it together from other things. When we are together in class, it's a time to ask questions. It's a time to do a ton of examples. It's a time to talk about the homework. It's a time for us to problem solve and bounce ideas off of one another and clarify, because I think that's a really useful way to utilize each other in that sense. So lots of examples, lots of problem solving, lots of things. In my mind, the course log sort of exists because then whatever we're doing in class, there are points to be had from filling in what we did in class into a written document that you all have access to so that anybody who's not in class on a given day still knows what we did in class that day without having to try to like do two things at once. So I think that that's the dream. The dream is every day before you come to class, you're going to watch a couple of videos. Not as many as you've had to watch on your own because you've had like a whole week to do at a time that's asynchronous, right? Couple videos before class one day. Then we get here, we talk about those videos, we do some examples, we clarify, and then we repeat the next day. So that's the dream. Couple videos, come to class, talk about it. Couple videos, come to class, talk about it, work examples, problem solve, whatever. That's the general format for what we're meant to do. And quizzes are a big question mark for me. But in general, I think quizzes are my way of checking in to say, like, did you watch the videos? Because the last thing, that this will all fall apart if people don't watch the videos and if they just show up and are like, hey, what I missed, tell me about it. Then we don't have time to do examples and clarifications because we're trying to like fill in content and the whole thing will fall apart. So my quizzes is just like my method of keeping you accountable for like, did you watch a thing? I think that's almost all of the questions that I had in the course log in some way or form. There's actually two more little questions on here, but before I move on, I want to pause and see if you all have other questions. Feel free to unmute and ask them or type them in the chat, whatever you want to do. Y'all are very quiet. I could take that as we all feel awesome, but that's dangerous. I need you to do your work, please. You need to do your work, please. Okay. I have two other little questions and then we can do abstract algebra because it seems like that's what you're super excited about today, which is cool because I am too. One other question was, how about if we answer something on the homework and we take a different approach than what you did in class? Like, is that acceptable? So let me answer that question because there's a complicated answer to that question. In general, that is yes, but sometimes in abstract algebra, that is no. The reason for this is we are learning abstract algebra in a particular order, and there are some really advanced techniques that you could find easily on the internet, for example, that would be inappropriate for this course. So a lot of times I'll ask you to prove something, and I want you to prove it given the knowledge that we have, not the universal knowledge that anyone who knows abstract algebra might have. So the general rule of thumb is if you prove something in a different way than the way I proved it, but it's using stuff we've all talked about in class, that's totally reasonable. People have different thought processes and different people have different ideas. And I want, if you thought about a problem in a particular way and it made sense to you, that's awesome. And I want to give you credit for it. If you come in and you start solving problems using CELO theory, and I'll know that you, and like, you're like, but if you just use CELO theory, this is a really easy problem. I'm going to say, where on earth did you learn about CELO theory? Because I know I didn't teach it to you. And I know you didn't jump ahead 20 chapters in your textbook in order to get to CELO theory. That's not an appropriate tool to be using right now. You need to use the tools that you have. So just be cautious of that. If you just thought about a problem in a different way and you like wanted to write that up instead of what I was hinting at, but it uses everything we've done in the course, that's totally fine. But if you start quoting really powerful machinery that you do not have the tools to understand yet, I'm not going to give you credit for that because it means you just accessed it from a different source. That different source could not possibly have explained it in an appropriate way because it's just too powerful of machinery, and I'm going to say no on that. So my CELO theory is the example, and I'll also know you did it because you won't pronounce CELO correctly because it's not spelled the way that I'm saying it out loud. Anyway. A perfect example of that is on your last homework assignment, there was the question about least common multiples. And I had sort of a follow the definition type breadcrumbs thought as to how you would approach it, because that was the most similar to what I did in one of the videos that I gave you. So I felt like that would be the most straightforward and most commonly approached method of attacking that problem. But there's a totally different way to approach that problem using prime power factorization. But that's totally cool. I talked about prime power factorization, and that's a different method of approach to the problem that makes sense with the tools that we have. So that's a fine example of approaching a problem in a different light. But if all of a sudden you're coming in and using like advanced number theory and like Lagrange multipliers to do something, I'd be like, that's not important here, right? Like that's a way improper way to be handling this particular problem. So that's not an answer you want to hear, but just be cautious with the internet. If you're using the internet to teach you things, make sure you're citing that source so I know where you're getting that information from. The last question I had was, can you elaborate on like computer technology or other things that will be allowable for when we're taking exams? Sort of. I can sort of elaborate on that. For the most part, I have a calculator computer ban in that it won't help you very much. Just abstract algebra, when I'm talking about like moving a square and what picture does it make, your calculator just doesn't have a function for that. So there's just no purpose in having a calculator for that. And likewise, we don't actually do a huge amount of computation. We don't actually do a huge amount of computation. And so the calculator just doesn't help. Excel is actually very helpful as we're doing abstract algebra. Making tables and coloring things in Excel is a thing we do a lot. So typically what I have in my mind is that you can use Excel on exams, but that your calculator you can't use. And I guess if you really desperately wanted it for comfort, I don't have a problem with it. I just don't think it'll help you unless you're physically moving it for motions of a rectangle. Like, I don't know if it would be helpful. But I think in general, we'll have to cross the midterm boat when we come to it, because how I would design an in-class exam and how I would design an online exam would be different. And God only knows how long we'll be open and if we'll be together on an exam day or not. So that I think I will have to just get more specific about what's allowable on an exams based on if we're taking it in person or remotely at that point. That's all the questions. So I'm going to set a timer for 1 minute. I'm going to give you 1 minute to think about if you have more questions and you want to unmute and ask them or type them in the chat. And then if you don't, we can do abstract algebra. Thank you. Here. Awesome. Okay. Question about the final. We do not have a final exam. We have a final project. Because I think somebody did ask me what the last week of classes will look like too, since no matter what, we're remote from Thanksgiving onward. My dream is that we will take our final in-class exam, should we still be together, like right before Thanksgiving. And that'll just be a third exam. It's not a cumulative exam. It's not a final exam, whatever. But we'll take that right before we leave. And my dream is to give you the whole last week of the course, which is that remote learning instruction, to work on your final project. So your final project is to investigate something about abstract algebra and then write that up and add it to the course log. And we can talk about more details of that whenever you'd like. But the point is you'll investigate something that was of interest to you from abstract algebra and write something up. So if you were like, man, spider graphs are just the best, like you could write about spider graphs, and that could be your final exam project or your final project. Other questions or comments, concerns? Life, the universe, anything? You good? You're excited? You want to do abstract algebra?
Thumbs up!
I know, they can do little thumbs up and emojis. Clara wants to do abstract algebra. She said she likes that I'm so enthusiastic with you.
Thumbs up!
Yay, okay. Well then, yay! Like Liz's reaction.
Thumbs up!
That's good. You need to do your work now. Cool. Okay. If you want to take a look on Schoology, I have a worksheet for us on Schoology. Markwell says your enthusiasm is rubbing off on him. He's enthusiastic now too.
Schoology.
If you head on over to Schoology, there's a worksheet that's on Schoology. I can also bring it up and share it with you on my screen, which I might as well do.
What Schoology?
Okay, cool. So you should be able to access this worksheet. It's posted on Schoology, but I have it for you here as well. I think what we're gonna do is start. I wanted us to focus today on that definition of a group, because what we need to do is build a gigantic arsenal of examples of groups. I will take the whole week to do that if we need to, because it's really, really important. But before we get there, as a warm-up, I want us to make sure that we fully understand binary operations. So I put a collection of binary operations over here in example 1 on this worksheet. What I think I'm going to do is put you all into breakout rooms. So I will give you 3 minutes to look at this, which is not enough time, 3 minutes to look at example 1 with the binary operations and try to get a yes, no answer, a yes, no, I don't know for 1 through 10 in your first 3 minutes. And then I'll put you into breakout rooms for about 5 minutes so you can talk to each other and you can call me in to ask questions if you want to. And then when that's all done, we'll come back and we will meet together and we'll just go through them one by one. So I'll call on your groups and I'll say, group 1, what did you think about problem 1? Group 2, what did you think about problem 2? Whatever it might be. So let's do that. I'll set my timer, 3 minutes. Take a look at those 10 examples and non-examples of binary operations and see if in the first 3 minutes you can get a yes, no, I don't know for every single one of them. And then I'll put you into your breakout rooms. Good? Clear?
Thumbs up.
I'm assuming so. So I got my timer. Yay, Kyle. Thank you, Kyle. Here we go. 3 minutes on your own, and then I'll put you in your breakout rooms. It's 1, yes.
1, 2, 1, 2. It's going to be 16 minus 14 is 2.
Okay, I'm gonna open up your breakout rooms and then I'll set a time for like 5 minutes. I hope that that's reasonable. I'm totally guessing on these times, so feel free to like return to me if you're done in your breakout room. But breakout rooms are open. Go ahead and join in and let me know if you have any questions. Yes, now everything looks good. Do you have to do the rest of these?
No, just one.
Just one page?
One page every day.
There we go.
I'm not good at cursive P's. I only have 15 minutes on my tablet. Anyway, Nobel Prize. There's like a gold chapters. Finished. Now I can clean my tablet till it's 10 o'clock, which is in about 15 minutes.
You can play on your tablet right here so that I can make sure that you get back to your meeting with Mrs. Lochtefeld.
How many questions?
Honey, if you're gonna have the volume on, can you go at the dining table? Because otherwise my students will be able to hear it.
Or I could just turn this on. What's this going?
Yeah. Oh, it's hard.
say S. If you do
Okay.
that binary operator, your output is going to be in S still.
All right.
I'm bombing your room because I'm trying to figure out how this works. How you doing?
Doing all right.
Not
All
bad.
right. Okay, I'll leave you alone. I just wanted to check in.
Oh yeah,
Okay.
we're on. We're almost done. We're on 7 now. Going for-
Awesome. Perfect. Where did the breakout room thing go? Hi, breakout room.
Hello?
We are stuck on 5, 7, and 9, and maybe 8.
That is good. Those are the ones you should be stuck on.
Okay, cool.
So that's reasonable. I'm going to end the breakout rooms and then we'll all chat about everything together. But good job. Okay. Everyone's coming back now. I think I've got you all. Yay, okay. So here's how we're gonna do this. We've got 10 questions. There were 4 groups. I've got the name of a representative from each group, and I'm just gonna call on you and say, hey, what did your group think of this problem? And if you don't know, that was an acceptable answer. Remember, the answers were yes, it is a binary operation, no, it is not a binary operation, and I don't know. So those are acceptable answers. If you get called on and you don't know, we can just bounce it to the next group. Cool? At least one cool. Okay, I take one cool and I'm like, yeah, that's good. Awesome. So our first group is Aaron's group. Aaron, what do you think about the first example?
Our group thought the first example was not a binary operator.
Awesome, you are absolutely correct, Aaron. So what, do you have an example to show why it doesn't work or a reasoning?
N is the natural numbers and 0, it needs to be included.
Sure, right. If I picked up
with.
If I picked up 2 numbers that were the same and I performed a subtraction, I would get 0, and 0 is not there.
Yeah.
Perfect. Awesome. Thank you, Aaron's group. Everyone feel good? I think I snuck in on 1 or 2 groups and asked them how they were doing, and the questions on these tend to be sort of similar. So I think normally people feel pretty good about 1. So if there's ever one you want me to talk about more, if you want to just throw it up in the chat like, no, I want to talk about this more or whatever, just feel free to do that. So until then, I'll just move on and I'll say, how about Benjamin's group? The next group was Benjamin's group. What do you think about number 2? Are the integers, that's what the Z symbol is for, are they an operation, a binary operation under subtraction? For Benjamin. What do you think, Benjamin? Ah, Benjamin doesn't have access to his mic. So who else was in Benjamin's group? I can see if I can.
I was, and we said yes.
You said yes, it is a binary operation.
Yes.
You are absolutely correct. It is. So good work. Okay. So we'll do Burke's group. Okay. Cool. Awesome. How about Kyle's group, number 3? What if we have the integers and the operation is division? Is that a binary operation?
We said no.
No, you're absolutely right. How come?
Our example, like top of the heads, we just said if you did 4 divided by 3.
Yep, good. See, you watched the videos. You passed my quiz. 4 divided by 3. That is not an integer, and so this doesn't work for number 3. Excellent. Okay, Lexi, how about number 4? Lexi's group.
We said yes.
Yes. So this one's a little weirder because we're not talking about like a numeric set and a like mathematical operation, but we're looking at the set of motions of a square, which we did in our little knitting video, and we're just combining motions by doing one motion and then doing another motion. If we have the set of all symmetries of the square, that's going to work out. So it's a weirder example, but you're absolutely correct. That is a binary operation, which is half the reason we did that one, right? Perfect. So 4, very good. How do we feel about the first 4? Thumbs up, no need to talk about those further?
Pretty good. Pretty good.
Okay. I'm gonna pause before I circle back around to you all, because there has been some talk about like how are we gonna use the course document and like how are we gonna make this useful. So I wanted to show you one thing that we could be doing. So I'm gonna share my screen again for 1 minute. So you can see this side by side here. I have the document we're working on over here on the right, and then I have our course log over here on the left. You can see this, yes? I believe so. Anywho, here's what I could do. Maybe we want to keep a log of our answers for these problems. I could pop on over to the course log. I could just start a new page, insert a page break, and I could say answers to worksheet 1. If I highlight this and I format it as heading number 1, and I apply heading 1 to it, and I center it, I want to show you a cool thing. Formatting it as heading 1, if I go back to the table of contents and I refresh it, now there's a link for it in the table of contents. And if I click on that link, it'll take me directly to that point in the worksheet. So if you don't work with Google Docs a lot, I don't, because I use tech for everything. That was like a thing I had to look up. But we could come over here and we could like be typing the answers to these various things. There's another cool thing I want to show you with Google Docs at some point in time. Let me just do it right here. So what was one of the examples we were looking at? S is the natural numbers and the operation is subtraction. Maybe I want, like, how do I do the S is the natural numbers thing? And the operation is subtraction is pretty easy to just type. I have a plugin for my Google Docs. So I can type in tech. And this is one of the reasons I was going to say, maybe we should all learn to type in tech because it's way easier, in my opinion, than the crappy equation editor here. Maybe I want to do the natural numbers. So S is equal to, the command in tech for that is math BB, curly braces, and then an N. And let me see if I can then do my auto tech equations and hit start right here. And it will render all equations if I push that button. Boom! Pretty. So there's a little bit, you don't even have to learn much tech. That's not so bad. And then if you wanted to go back and see what it looks like, you can hit de-render all equations and it'll bring it back to what the tech is so that you know what that looks like. And you could work on typing things in that way. So anyway, I'm gonna stop sharing for a moment and get us back to here. So just so you're aware, that's a thing you could do and it's kind of cool. And I think that might help if we're in this kind of environment and we're trying to collaborate. In addition to our little whiteboards, if we need to communicate with each other, we could type in the course log. Anyway. Let's return back to our examples, shall we? Let's get back to example 5, where S is the set of real numbers. And then the notation is a little bit weird, but what's our binary or our dot operation going to do? It's going to pick up any 2 real numbers. It's going to pick up A first, and then it's going to pick up B, and we're going to combine them in the dumbest way possible, which is just throwing B on the ground and holding on to A. It's a thing I can define. The question is that a binary operation? Aaron's group, what was your discussion like for that one? How did you feel about that one?
I think that we were definitely a little confused on it, but
Okay.
we ended up coming to the conclusion of yes. I think mainly because we're just kind of assuming that A is going to be in the real numbers. So since you're starting with an operation that's in the real numbers and yeah, your output is also in the real numbers, we're just going with yes.
You're going with yes is a great idea. That's exactly right. It's kind of a weird operation. We pick up two things and we combine them somewhat vacuously by just ignoring one. But in the end, you picked up two real numbers and you came away with a real number. And you could do it all the time. It's a stupid operation, but it works. So example 5, exactly correct. Aaron and Cody's group, that is a binary operation for number 5. All right. So we're back to Benjamin's group, but Benjamin doesn't have a microphone, so we moved on to Brooke, and Brooke was acting on behalf of her group. How about number 6? S is the set of even numbers, and two even numbers are combined by multiplication, taking their product. What do you think?
We said yes for that. I wasn't sure about that though, so I think Roman is the one that said yes about that one.
Sure, Roman, do you want to elaborate a little bit on your thinking there?
Yeah, let me just pull up which was number 6. So for this one, it's the two even numbers. So my process of thinking was when you take the product of two even numbers, yeah, when you take the product of the two even numbers, we're eventually going to end up with an even number as
How do we all feel? I feel pretty good about it. Everyone else, can we get a thumbs up for
Yes,
Roman?
I'm here.
Or no, could you explain more?
Can he say that again, just real quick, because I couldn't really hear him. He was quiet.
All right, sorry. Yeah, so when we're taking the product of two even numbers, you're going to end up with the answer as an even number. So that was my process of thinking it.
Okay,
When we
thank you.
multiply two even numbers, we get an even number. So we're good to go. Quite right. Awesome. Okay. Let's move on to number 7. That would be Kyle's group. Kyle, how did you feel about number 7? What was your discussion like there?
We said no, just because we thought, like, I don't know, our reasoning was if we said like the 2 points are the same, there'd still be a point, like just 1 point.
Ah, very good. Okay. So let's so Kyle's group thinks this is not a binary operation. Let's make sure that we're clear on what the binary operation is, because every now and again, this one, people are like, what are we even doing? And the idea is like our set is a Cartesian plane. And we have to pick up two things and know how to combine them. So one thing we do a lot in the Cartesian plane is pick up two different points. My screen is like mirrored, so it's really weird. And we draw a line through them. That's a way we often combine 2 points in the plane. It's a very mathy thing. But what Kyle was hitting on is that this is actually not a binary operation despite its inherent mathiness. In part because how would you combine a point with itself? If I picked up 1 point and I picked up the same point the second time around, how would I form a line out of just 1 point? So the operation doesn't quite make sense in that instance when you pick up a point with itself. I wouldn't know what the output would be. And so I don't think that this should be a binary operation. I'm summarizing what Kyle said, not I think, right? What are your thoughts, groups? Agree, disagree? Other things that were good or bad about this example, confusing for you or on your mind as you thought about this one? Because this one can be a harder example.
I thought it was confusing because we're looking at like 2 points, like those are our inputs and what we're getting out as a line. So it kind of makes it feel like in the video when you talked about like getting an elephant as an output, like it makes it feel different. But since the set is R2, it makes me it makes me think that the line does line R2, meaning it would be a binary operation. So I'm kind of confused.
Yes, that is another good point to bring up. So in fact, the way that Marquel was talking about that at first is a thought process that I want you to have, right? I'm supposed to pick up two objects that are alike in some way, combine them, and get another one of that same object out. So if my objects here are points in the plane, and I'm combining them and I'm getting a line, haven't I jumped outside of my set? I took a point and I combined them and I got a line instead of a point. So this fails to be a binary operation for that reason as well. It is true as, and I mean, and Marquel then got to, well, but that line would live in R2 and isn't our set R2? That's a good point. What we actually have when we have a line is we have an infinite collection of points instead of a single point. So it's still, our answer is still a subset of the set we're working in, but it's not a subset of the right size. It's not an element of the set that we're working in. And that's the difference that we're seeing right here. So this one is a very mathy thing to do. We do it all the time. It's a thing, but the word to describe it is not binary operation. Sometimes when people come up with the point that Marquel is making of, but I've got this infinite collection of points instead of a single point, I'll sometimes say, okay, maybe we could fix it, right? Maybe we could change the binary operation so that maybe we pick the y-intercept of the line. And maybe that would work. And that still doesn't work for the reason that Kyle's group originally brought up. We still wouldn't have a way to combine a point with itself. And if I pick the y-intercept of the line, what do I do for vertical lines that might not have a y-intercept or have infinitely many y-intercepts? So it becomes very complicated in that sense. So really 7 is meant to be not fixable as a binary operation. Sometimes, like we saw in the video talking about what a group is, sometimes we'll have a problem with a set where it doesn't manage to be a group, and we just have to tweak it a little bit and we'll be able to fix it. But 7 is really fundamentally unfixable despite its mathiness, and that's part of the reason that we have it as an example here. That one's a hard one. Further questions, discussion, things you want to add, things that are still fuzzy for you? Yay! Somebody's like, yeah, no, we're good. Let's keep going. Let's, just so that we get through the rest of them here, let's move on to number 8. And I think we're back at Lexi's group. S is the set of vectors in 3 space. And we're going to take 2 vectors and combine them by taking their cross product. Now I'll let Lexi's group and Aaron's group pair up on this because Aaron's group is where we're going to cycle back around to next, and 8 and 9 are somewhat intimately related. As you may guess, the answer to one of them is yes and one of them is no. So what do you think, Lexi's group and Aaron's group?
I have no idea. Sean is the one that had an idea in our group, and I got nothing.
Okay, well, pass the ball to Sean then. Sean, what do you think?
So I thought that maybe 8 would have been no, because when you take like 2 vectors like in a plane, the cross product will be like normal to that plane. But since it's in 3 space, I wasn't sure because it's still a vector in 3 space, whether it's in the same plane as the first 2 vectors or not.
Gotcha. So you were saying, I see how I'm going to take 2 vectors and combine them to get another vector, but is that vector in the right region? Like I'm taking 2 vectors to get a vector, but will I get a vector that is in the right place? What do you think, Aaron's group? Any thoughts?
Going off of that, I think it was Calvin that kind of had that similar idea of when you take the cross product, you're going to get a vector, and when you're taking the dot product, you brought up that you're not getting a vector, you're going to be getting a single point or value. So we said that 8 would be yes, since you are getting a vector out of 2 vectors, and 9 was no, since you're just getting a single value out of that dot product.
So I like that. I like the process of elimination approach, right? I do try, I don't always succeed, but I do try to often set things up where the answer to one is yes and the answer to the other is no. So I did do that here. I tried to set up 8 and 9, so one of them is yes and the other one is no. And now I'm not sure who was speaking, if it was Aaron or Kelvin at just this precise moment, or still Sean, but somebody had a good idea and one of you gets credit somewhere. That the dot product is a mechanism for taking 2 vectors and combining them and getting a scalar, getting a single number. And that is not a vector. And so that's like taking 2 things and 2 numbers and combining them and getting an elephant. You're combining like with like and you're getting not alike. So the dot product example, again, a mathy thing we do, a good mechanism for combining things, but not a binary operation. And so if the dot product doesn't work, then it must be the cross product that does work. And the cross product does work. So to clear up if I'm getting a vector, when I take the cross product of 2 vectors and I get a vector that's perpendicular to it, is that still in R3? Yeah, it's just going a different direction in R3. Like R2 is our standard plane there. If I was getting that other unit vector, i's and j's, and getting a k, I'm still living within R3 when I'm the vector 0, 0, 1. So it is okay. It's 2 vectors that you're combining to get another vector, and that vector does still live in R3. So the answer for 8 would be yes, and 9 would be no. And one way you could have gotten that yes for 8 is just by knowing that the answer for 9 was no, and that would be okay. Doing all right? All right. Brooke and Benjamin's group, I'm going to give you a break on number 10, because I did number 10 in the video. I know I did that one, because it always reminds me of that book, The Color Kittens, and I put the little picture in the slides. But I mentioned that last time I taught this course, and I think The Color Kittens is like not a standard work of literature for small children. So I'm assuming that none of you know what The Color Kittens are, but it's a weird, crazy book about making colors. Anyway, I like the Color Kittens. You have the Color Kittens too, Liz? Oh, that makes me so happy. Somebody knows about the Color Kittens. It's all I can ever think of. Anywho, so let's pause and take stock where we are. Yes, and the color mice. How do we feel about binary operations? Feel like those examples help? We had a couple in the videos, but now we've done a bunch more, so hopefully they feel all right. Yay, okay, good. Here's where we're gonna be. When I take a look at example 2 should take us all of Wednesday's class at the very least. At the very least, all of example 2. What we're gonna do probably when we come back next time, here's how I think we should do this, because we have 10 minutes of class left. I think we should walk through the first 5 as a group today. And then when we come back on Wednesday, for example, we'll keep going with example 2, 6 through 20. I'll put you into breakout rooms and I'll pop between the breakout rooms on Wednesday. We want to see if we can handle these. So I'll hand chunks to individual breakout rooms, like 6 through 10 to one breakout room and 11 through 15 to another breakout room or whatever, so that you can focus on a handful of them. And we'll want to then come back as a big class and discuss every single one of them. Because the way that we're going to go, once we have a crap ton of examples of groups, that's when we can start moving on and noticing patterns about groups and finding similarities between certain groups and big differences between others. All of those observations that will come up in the process of doing examples will be really helpful to us to keep in our mind. And when we start doing more intricate group theory, we're going to want to try out conjectures on different groups and different families of groups. And so it's real important for us to feel comfortable with the types of examples that are going to come up here and be able to move from one group to another group to another group. So how does that sound for a plan for today? Work through 1 through 5 today and leave 6 through 20 for Wednesday's meeting? Thumbs up if you're cool with that. Yay, thank you for the thumbs ups. Awesome, okay. So let's do the thing that we did again. I will set this time just a 1-minute timer for you to think on your own about the answers 1 through 5, because I think a 1-minute timer is sufficient. And then we'll just talk all together. So yes, no, I don't know. For 1 through 5, 1 minute. Oh, do you want me to screen share with you? Awesome. Okay. So we have a yes, no, I don't know for 1 through 5. Does anybody have a yes or a no for 1 and feels really good about it and wants to share it with everybody? Do the natural numbers form a group under addition?
I believe it would be no, because it doesn't have any associativity.
You have the correct answer of no. That is absolutely correct. But addition here is associative. We do have associativity with addition. So it's not associativity that's the issue.
All right, would be identity then?
Yeah, we don't have an identity. 0 is not a natural number if you're a mathematician. It is if you're a computer scientist, but in abstract algebra, we're all going to be mathematicians. So we're going to say that 0 is not a natural number. And we would need 0 in order to be able to add it to something and have it not change that value. So the answer for 1 is going to be no. Natural numbers are not a group under addition. Good? Somehow it's more fun for me to do it as my real thumb instead of the thumbs up gesture. I don't know why. Yay, okay, 1 good. Thank you. How about the integers under subtraction? Anyone? Maybe if you don't want to like gamble because you might be wrong, maybe you just are like, here are my thoughts on 2, and you can leave it to us to like infer if you're giving a yes or a no. Is that a good way to like make it more enticing to speak up? Or else I can unmute you randomly and force you to talk, but that's way less pleasant for everybody.
I'm thinking no, just because my source of thinking is you don't have like the inverse. But that's just me.
Cool, awesome. Okay, so Kyle thinks the answer is no for number 2. He's worried about inverses. Oh, something went ding ding. Somebody wants to join, I think. Oh, Liz got kicked out. Okay, cool. Anyone else have thoughts? Maybe let's go through 1 by 1, right? If I have 2 integers and let's look at closure. If I take 2 integers and I subtract them, will I get another integer?
Yes.
Yes, you're right. I will get another integer if I take 2 integers and subtract them. So this is closed. This is a binary operation. The set is closed. How about associativity? Is subtraction an associative operation? Now, I know that associativity is a weird thing to talk about, and I even mentioned that in the video. So what I would do is say, like, at least try some examples. pick a couple examples and do subtractions and check to see if it's associative. Is subtraction associative?
For this one, like how it has an example, it has A, B, and C in the same order, just regrouping the parentheses. Is that always the case, or would there be a case where you switch around where A, B, and C is? Because I think if A, B, and C stay in the same order, then yes, but if not, then no.
So that's a good question. I'm gonna write on my little board. So Markel is saying, like, there was a big point in the video where I talked about you put your numbers down for your A's, B's, and C's. And then what all you're gonna do, you have to keep, I have 5, 4, 3 in one direction. I need 5, 4, 3 in the other direction. What I need to do is put parentheses in there. So on the one hand, associativity would be saying, this is what associativity says. Can I move the parentheses? Are those two things equal? Notice that it says 5, 4, 3, 5, 4, 3. I've just changed where the grouping is. When we're talking about associativity, we always want things to stay in the same order. We don't allow the changing of the order. That is a commutative property and just like totally disjoint and separate. And I think what you were getting at, Markel, is that subtraction is not commutative. 5 minus 4 is not the same thing as 4 minus 3. So this is definitely not a commutative operation, but that's okay. We could forgive that. So my real question is, I don't know, I picked a random example. Are those two things equal?
Yeah.
We vote yes?
Yes.
Okay, let me show my work. Are those two things equal?
No.
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 But is what I wrote equal to the top line?
Yes.
So is it associative?
No.
No.
No. If I change the parentheses with subtraction, I get a different answer. All right, I was really ambitious with 1 through 5. We got through 1 and 2. I told you it could take all week to do these examples and I would be okay because we're at time and I think you all need to go. Here's where we'll end for today because I think it's a good one. Subtraction is not associative and that's freaking mind-blowing because the integers are a group under addition, but they're not a group under subtraction and that feels weird. But here's my promise to you. Associativity is weird, it's annoying to check, and it doesn't really make sense as a thing that comes up in the group operation. So my deal is, I burned you once. I will not burn you again. All the remaining ones will have associative operations, 3 through 20. So you don't need to worry about associativity ever again because I burned you just now. So that's the deal I'll make. I won't burn you again. We saw an example where associativity fails. It won't fail again. Okay. When we come back on Wednesday, we'll pick up with the rest of them, 3 through 20, and we'll work on them all together, go over every single one. Watch your email for that homework problem. I want to give you somebody else's homework problem to provide feedback on. So I need to get those typed up and sent to you. And you have a quiz for Wednesday. Take a look online for that. But you don't have any videos to watch. We're going to come back Wednesday and work the rest of the examples. Cool? All right. You all are free to go. It was good to see your names and talk to you. And I'll see you on Wednesday in some form.
Thank you.
Thank you. I do have one question real quick.
Oh yeah, sure. What's up?
It's more just for like last week, the community points and stuff. Has that been entered in, or like how are you doing those?
I think I entered them in. What I'm doing is keeping a spreadsheet of ways to earn community points by week. and then I'm just entering it in once you've done something. So if I don't have it, if it's entered in right now and it's not correct, it might be that you went to the SI and I didn't know about it because that was a missing variable for me until recently, or I might just be missing something. So what I have entered in, if it's not right, just let me know and I'll get it fixed.
Okay, just because like I did everything from last week, but like I don't have like all of it entered in, so that's why I was just wondering.
Okay, so tell me, so what did you do? List the things that you did, and then I'll just go put the right amount of points in right now.
Because I put stuff in on the course log last week.
Okay.
Added a question, in the questions for the 14th or today.
Okay.
So I did a whole row in the Kaylee table.
Gotcha.
And then me and a few other people we met with, Lexi last week, and then we did the whole group chat thing. I think it was last Wednesday.
Okay. So I should have 4 points for you, I think, because I think I counted entering in the Kaylee table as doing something in the course log.
Okay.
But I'm not sure. I'll look at the directions again because I might have communicated that as like an additional thing. And then if I didn't count it that way, there would be a lot of people who like didn't get the right amount of points. So I'll look at it. I'll have at least 4
realized it was
then, and then maybe 5 if I counted those separate. Yeah.
Okay, yeah, that was my question because I didn't know if those were dual or if it was like separate.
I'm not sure that I was clear on that. So I'm going to go back and take a look. And I'd frankly rather be generous than stingy. And I think right now I've been stingy. So I should probably go back and just give like extra points for that.
No, that's okay. I just wanted to double check with everything from last week, just with.
Yeah, no, I appreciate it. I mean, I wanted to keep track.
about the
There's
same
like lots of room for accounting error, you know. So it's just always good to be keeping track and like let me know, and then I'll just fix it. So.
Oh, okay, thank you so much.
Yeah.
I wanted to talk to you about the same thing actually.
Yeah, let me know.
So I got 2 community points, which is fine. I just wanted to let you know, I did the proof in color. I did a line. I asked a question. The 3 things, I added you on Snap like the day before they were due. So I submitted it over Schoology.
Okay, yeah, I should submit if it was over Schoology.
And then I made an appointment on Wednesday with you.
Oh, okay. I understand. Okay. Yeah,
Okay.
so then I don't have yours logged. So I think I was giving points to people who I saw in office hours that week.
Oh, okay.
So how do you want to do that? I'm happy to do it either way. Do you want to move that community point to like this week so that when you were in, like when you scheduled it, you get the point?
Yeah, that'd be awesome. That way I can start fresh and do 4 more for this week.
Yeah, I got you. Okay.
That'd be awesome.
So that one I definitely didn't have because I was like, well, I didn't see you at office hours, but it's, I can move it and that's totally fine. And I can give you credit for scheduling it. And then like you said, you don't have to do like an accounting.
Oh, okay, awesome. Thank you so much.
Yeah, no problem. I'll see you,
All right.
later.
Bye, thank you.
Bye.